Okay, here we are in lesson 2, proportional relationships. So before we get started, there's two things that I need you to write up at the top. So in this lesson, we're going to start looking for what's called the constant, which is represented by the letter K. Alright, and to find the constant, you are always going to do y over x. Alright, so make sure you have that written down. And then the other thing is the equation for a proportional relationship is y equals kx. And we're going to be using both of these things. Just write yourself a little note again that k is the constant. Alright, we're going to look here at example 1. It says a new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of yogurt and its toppings in a dish. Each member of Isabel's family weighed their dish, and this is what they found. Determine if the cost is proportional to the weight. So whenever we see the word proportional, we're always going to be looking for a constant. So in these tables, the first value is always going to be x, and the second is going to be y. So we're trying to figure out if it's proportional, so that means we have to see if there's a constant. So we'll just go ahead and we're going to start calculating here. So we're going to do y over x. So first we would have 5 over 12.5, which if you did that in your calculator, you would get 0.4. And now we're going to check 4 divided by 10, and if you did that probably in your head, you would get 0.4. Now we're going to check 2 over 5, which in your calculator again is 0.4. And then last we have 3.20 over 8, which again, if you plug it into your calculator, is 0.4. So we can say that the cost is proportional to the weight. Alright, and to write our equation, we know our constant k is 0.4, so we can say k equals 0.4. So our equation would be y equals 0.4x. Alright, that's all we have to do for that example. So go ahead and look at example 2. And this says, in the back of a recipe book, a diagram provides easy conversions to use while cooking. So we're trying to figure out again if this is proportional. So cups is going to be x, ounces will be y. So we're trying to find a constant here. So first we're going to do 4 divided by 1/2, which is the same as multiplying by 2, so we'd get 8. And then we're going to check 8 divided by 1, which we see is 8. And then we are going to do 12 divided by 1.5, which again is actually 8. And then last we have 16 divided by 2, which we all know is 8. So we can say that the ounces is proportional to the cups. And our equation here would be y equals 8x. Okay, so go ahead and flip over to the next page. Should be on page 5 now. And this is the last example we're going to do all together. So it says, during Jose's physical education class today, students visited activity stations. Next to each station was a chart depicting how many calories on average would be burned by completing the activity. So part A says, is the number of calories burned proportional to time? So again, we're trying to see if there's a constant. So time is going to be x, calories is going to be y. So we're going to start checking. So we're not going to do 0 divided by 0. That one doesn't really count. So we're going to look at 11 over 1, which is 11. Okay. Now we're going to look at 22 over 2, which is 11 again. So we're still good. We're going to look at 33 over 3, which is 11. And then last we have 44 over 4, which is 11. So we can say that yes, it's proportional because there is a constant of 11. Right, and then our equation here would be y equals 11x. Okay, so now part B says, if Jose jumped rope for 6.5 minutes, how many calories would he expect to burn? So we know that x equals minutes from our visual above, and y equals calories. So we're going to use our equation that we just wrote, y equals 11x. We know that he jumped rope for 6.5 minutes, so we're going to plug that in for x. So we'd have 11 times 6.5. And when you plug that into the calculator, you do get 71.5, and this would be calories. Right, and that is your answer. Right, we are going to do the next example in class all together, so don't worry about doing that on your own, and we'll do that in class tomorrow.